So now let's look at reference angle. Okay, so the first thing, what is the reference angle? The reference angle we denoted by r, theta r. Okay, r represents the reference angle of angle theta. The reference angle theta r over the angle theta is what? Which is the positive acute angle formed by the terminal side of theta and the nearest x-axis. Okay, so here the x-axis means the positive x-axis and the negative x-axis. So what does this mean? If the terminal side is here, if the terminal side of the theta is here, then the reference angle is acute angle, so which means greater than 0, positive acute angle, greater than 0, less than pi over 2. So it should be, this is the reference angle, which is the terminal side and the nearest x-axis, so the nearest x-axis, which is the positive x-axis, right? If the terminal side is in the second quadrant, this is the terminal side. What is the reference angle? Is the formed by the terminal side and the nearest x-axis. So the nearest x-axis is what? Is the negative x-axis. So this is our reference angle. So the reference angle is always, I should write here, so this is always positive acute angle, so it's always between 0 and pi over 2. Less than 90 degrees, right? If the terminal side is here, and what is the nearest x-axis, which is the negative part, right? So the reference angle is this one. This is the reference angle, right? We always take the positive. So we rotate counterclockwise. If the terminal side is here, what is the reference angle? The reference angle is this one. Right. So if, yeah. If our theta is here, if this is our theta, right? If this is our theta, so the reference angle is what? Which is theta minus pi, right? If this is our theta, and this one is what? Theta, or the reference angle is 2 pi minus this angle, right? Theta, if this is our theta. Here is the reference angle is what? This is a pi. If this is our theta, so pi minus theta. Okay. So this theta is actually the coterminal angle, so it represents the coterminal angles, which lies in the between 0 and 2 pi. Okay. So now let's look at this one. If our theta is negative 41 pi over 6. Okay, so this is a very large angle, right? Very complicated. We have several revolutions. So the idea is, if we want to try to find the reference angle, the only thing we need to know is what is the location of the terminal side, right? So we just need to find the coterminal angles of the theta. This coterminal angles is between 0 and 2 pi. Then we can locate the terminal side quickly, right? So you notice that our theta equals negative 41 pi over 6. It can be written as what? We just need to find the coterminal angle, sorry. So we needed to try, right, to make, so the first step, I should write down, first step is needed to find the coterminal angles. If this angle is greater than, it's not in the region from 0 to 2 pi, then we need to find the coterminal angles, which is denoted by theta c. C means the coterminal angles from 0 to 2 pi. So this is our first thing we need to do, right? How to find the coterminal angles? We know that if we want to make this negative angle to be from 0 to 2 pi, we need to add what? Add a positive multiple of revolutions, right? So this is 41. We can add, for example, we can add this 8 pi, 3 revolutions, right? Because you can just try, you add 2 pi, it's still negative, then we add 2 pi again, and we add 2 pi until you add 8 pi's, then you will get a positive angle, which is 7 pi over 6, right? 7 pi over 6. We can do that, like you can try to add 2 pi. No, not enough. Then let's add 2 pi again. No, not enough. Add 2 pi, not enough. Add 2 pi. Yes, that is enough. Then it's equal to 7 pi over 6. So in other words, the terminal side is 7 pi over 6, which is greater than pi, right? Which is here. This is the terminal side. So our coterminal angle is this one, right? Theta c. So this is our terminal side. And what is our reference angle? Reference angle is this one. This is our reference angle, right? So this is our reference angle. So here is, so the reference angle is what? Which is theta c is 7 pi over 6, which is greater than pi, so it's minus pi, right? So this is the pi over 6, right? So if our theta, another example, if our theta is equal to 24 pi over 9. So if you simplify, this one is 8 pi over 3, right? 8 pi over 3, which is greater than 2 pi, because 2 pi is 6 pi over 3. So we needed to find so it's not in the region. You needed to find the coterminal angles from 0 to 2 pi, right? So it's not in the region from 0 to 2 pi, so we needed to convert it to be a coterminal angle, which is in from 0 to 2 pi. So the first thing we need to do is to find coterminal angles from 0 to 2 pi. If it is from 0 to 2 pi, then you don't need to do anything, right? You just use that angle directly. So it's greater than 2 pi, so we needed to what? To make it to be between less than 2 pi, so we needed to subtract, right? Subtract 1 revolution, 2 revolution, until you have 0, from 0, greater than 0, less than 2 pi. So the coterminal angles is pi over 3, 8 pi over 3. Let's try minus 2 pi. We subtract 1 revolution first. So this is already equal to, we notice that it's equal to 2 pi over 3. So it's already between 0 to 2 pi. So that's enough. Then we can locate the terminal side. 2 pi over 3 is less than what? Less than pi. Pi is 3 pi over 3, right? So it would be here. 2 pi over 3. So our reference angle is this one, theta r. So here is 2 pi over 3. So what is theta r? Theta r, the reference angle is pi minus 2 pi over 3, which is pi over 3, right? So the same thing, if you have theta, which is from another example, theta is from 420 degree. So which is greater than 2 pi. 2 pi is 360 degree, right? We needed to find the coterminal angles, which lies in between 0 and 360 degrees. So how to get it? We subtract 360 degrees. So that is what? 60 degree. 60 degree is between 0 and 2 pi, right? 0 to 2 pi. So our terminal side would be here, right? Terminal side would be here. So the reference angle is this one. This is our reference angle, right? And this angle we already know, which is equal to 60 degrees. So this reference angle is 60 degrees. So now let's look at something different, okay? So now let's look at the trig functions of arbitrary angle, okay? Let's look at the tangent pi over 6, right? Do you remember tangent pi over 6 is 30 degrees, which is a special angle, which is equal to square 3 over 3, right? So the terminal side is here, right? The terminal side is here. And the reference angle is 6. The reference angle is pi over, the reference angle is pi over 6, right? If you look at this 5 pi over 6, which is equal to negative 3, right? Because in the second quadrant, so it's negative. So the terminal side is here. Okay, the terminal side is here. And our reference angle is what? Is still, if this is 5 pi over 6, 5 pi over 6, so the reference angle is pi over 6, right? Because add together should be pi. And the tangent 7 pi over 6. It tells you it's equal to square root 3 over 3. Okay. So the terminal side is here. So the reference angle is this one, which is theta r is pi over 6. And the tangent 11 pi over 6, which is negative square root 3 over 3. So this is the terminal side is here. 11 pi over 6 is, so what is this one? Right, this is 11 pi over 6. So if you add this terminal side, it would be 2 pi, right? So the terminal side must be pi over 6. So you can see that these 4, the only difference is plus or minus, right? We observe that the difference is between of these 4 trig functions is plus or minus, right? The absolute value is the same. And we also notice that these angles have the same reference angle, right? They all have the same reference angle. So in other words, so this one gives you some idea is, if you have an angle, right? If you have an angle, you find the reference angle first. Then to find the values of the trig function values of the reference angle. Then you just determine it's positive or negative. How to determine it? You're using the terminal angle in which quadrant, right? We know sine, cosine, and the tangent for the different quadrant, then you have the different sign, positive or negative, right? So now let's look at the example. So this gives you a very important information. So now let's calculate 7 pi over 6, cosine 7 pi over 6. So the 7 pi over 6, the terminal side is, we know it's greater than pi, so it should be here, right? And the reference angle, theta, reference angle would be equal to what? Equal to pi over 6, because this is 7 pi over 6. And from here to here is pi. So pi plus 6, pi over 6 equals 7 pi over 6. Right? So the first step, step 1, determine the reference angle, theta sub r. Right? Determine the reference angle. So we know that cosine pi over 6, this is a very special angle, which is equal to what? Equal to square root 3 over 2. Do you remember that? Okay. Then the next thing is, so that means this angle, this cosine function, should have the same absolute value as this one, but it should be plus or minus depending on the choice or depending on the terminal angles, right? Step 2. It is determine the quadrant. Determine the quadrant to get a plus or minus. Get the sign. Okay, so our cosine 7 pi over 6 should be equal to, let's look at it. The absolute value should be equal to this one, right? But it's in the third quadrant. The terminal side is in the third quadrant. The third quadrant is cosine is what? Is negative, right? Is negative. So it would be negative. So it's equal to negative square root 3 over 2. So now let's look at this example. We want to know what is cosine negative 4 pi over 3. Negative 4 pi over 3 is here. So the first thing is you needed to find the terminal side. So the terminal side is, of course, you can use the coterminal angles, right? And the coterminal angles and from 0 to 2 pi. So you need to add 2 pi until you have an angle which is greater than 0, less than 2 pi. But since this is very simple, it's just a negative 4 pi over 3, the negative 4 pi over 3, we know you just rotate counterclockwise by 4 pi over 3. 4 pi over 3 is here, right? So this is the terminal side, okay? So here is rotate, this is the negative 4 pi over 3, right? So the coterminal angle is always a positive angle, right? Which is here. So the coterminal angle is what? So this is negative pi, right? From here to here is negative pi. You needed to get from here to here, you needed to get what? Another negative pi over 3. So in the opposite direction, so it's pi over 3. Okay. Then you will have what? So cosine negative 4 pi over 3. So the x value should be equal to the cosine of pi over 3, right? Pi over 3 equals 1/2. But it's plus or minus that determine the quadrant. So this quadrant in the second quadrant, cosine is negative, right? In the cosine here is this is plus plus minus minus. In the second quadrant is negative, so we put negative here. So this is negative 1/2. Right? So from these several problems, we notice that if the angle, the simplest form, which is the denominator is 6, right? Then the reference angle is always pi over 6. If the denominator is 3, the reference angle is always pi over 3. Right? You can imagine if the denominator is 4, then the reference angle is always pi over 4. So this is in general case, right? So this is you can get the reference angle quickly. Okay. So now let's look at this example. Cosine 13 pi over 6. 13 pi over 6. Okay. So we know it must be equal to cosine, the reference angle is pi over 6. Right? Why? Because the 13 pi over 6 can be written as what? If you subtract 2 pi, so it would be pi over 6, right? Pi over 6 is, so the terminal angle, coterminal angle would be here, right? Pi over 6. And the reference angle is the same thing here, pi over 6. And it's in the first quadrant, so it's positive. So this is the square root 3 over 2, right? If you have tangent 7 pi over 4. And we know that it should be equal to the tangent of the reference angle, which is pi over 4, right? But it's plus or minus. Let's look at the terminal side of this angle. 7 pi over 4 is here. Right? The terminal side is here in the fourth quadrant. In the fourth quadrant, the tangent is what? Is negative, so it's negative. So this is the negative what? Negative 1, right? Okay, so now let's look at the last example. If the tangent theta equals negative 5 over 4, cosine theta is positive, then we need to find sine theta and secant theta. So the first thing is tangent theta is negative, right? Which is less than 0. So that means theta is in which quadrant? In the second and the fourth quadrant, right? And cosine theta is positive. So that means theta should be in the first and the fourth quadrant. So in other words, the theta is in the fourth quadrant, right? So in the first quadrant, so the terminal side is here, and it's equal to negative 5 over 4. Negative 5 over 4, so we pick a point, x, y. So we can choose x to be, in this quadrant, x is always positive, right? So we have two choices, right? Easiest choice, which is negative 5 and 4, or 5 and negative 4. So which one is the correct one based on the quadrant, right? In the fourth quadrant, x is always positive, so it should be negative. So the tangent is what? Tangent is y over x, right? Tangent theta is y over x. So we can take x to be 4 and y to be negative 5, right? Then the tangent theta would be negative 5 over 4. Okay, so the distance from the origin to this point, which is 4 square plus negative 5 minus 0 square, so negative 5 zeros. So it's equal to square root 41. So the sine theta is what? Is y over r. We saw it's equal to negative 5 over square root 41, right? Then we needed to find the secant theta. Secant theta is 1 over cosine, right? We know. So what is cosine? Cosine is 1 over cosine. Cosine is what? X over r. So this is the 1 over, this is the x is 4 over square root 41. So it's equal to square root of 41 over 4.